Welcome to Swadharma Education. Today we are at Ganpat University.
So this is the other part.
Oh wow! Can we say like it's a miniature of a factory? Or
Yes,
something like that.
Yes.
We have a great faculty also here, Mr. Jignesh Mewada, who is an alumni of IIT, and also he has done his research in mechatronics here in Ganpat University.
The people from like 6 students from Mechatronics department, along with the one faculty member, they are going to China for underwater competition.
China.
Yes. The students who registered here in a placement cell, they will have a 100% chance.
100%.
Yes, 100% chance now to place themselves in company, right?
100%.
Yes, 100%.
It's a robotic hand, sir.
Yeah, it's a robotic manipulator. It's a robotic system.
There is one startup in Hyderabad. They have printed the combustion engine for rocket.
Yes.
With the 3D printing only.
Yes.
Because what they are saying is, if you weld the materials, there is a thin line
Yes,
separating it.
Yeah. So it's not a perfect manufacturing.
Exactly.
So additive technology is there.
I'm feeling like jealous of the students here because to imagine this kind of things available. Welcome, sir. Thank you
Hello.
very much for joining us.
Hello.
Today, if you go to any factory or any advanced laboratories, there is no pure mechanical system because every mechanical system has some or other way, some electronic component integrated into it.
Yes.
So, which as a layman, we know it's a mechatronics, but people don't know much about it. Could you please explain what is mechatronics all about?
Yeah. So basically, mechatronics is a interdisciplinary branch.
Excellent.
Yeah, and in Ganpat University, it has been established in 1999.
1999.
Yes, so it is one of the oldest branch, I may
26
say.
years.
Yes. So we have a more than 25 years of teaching experience in this
Wow.
department.
Wow.
And department is, as I said, it is interdisciplinary. So it's a blended mixture of mechanical, electrical, electronics, and automation related subjects coming into the picture.
Electrical, electronics, automation,
Yes.
and then mechanical.
Yes. And if you look at the structure of mechatronics, initially the students will be able to learn fundamentals of the mechanical, electrical, and electronic subjects. And later on, we blended them with the automation subjects.
Okay.
As you said that in industry, the people are not looking for advanced systems, right?
Right.
When I say the advanced mechanical, that means what? We have a integration of the electronics component
Right.
into the mechanical.
Right.
And not only that, we have also the now smart systems.
Right.
We have a IoT, right?
Right.
That is industrial Internet
Smart
of Things.
manufacturing, they are
Yes,
calling.
smart manufacturing is coming into the picture. We have a robotics.
Right.
We have a control system. We have an embedded system. So everything is coming into the mechatronics.
Wow.
So what you said, it is, of course, it's one of the oldest branch, but at the same time, it is an emerging trend and it is an emerging branch.
Right.
The people who gone through the mechatronics engineering or the students who will undergo the mechatronics engineering, they can do a wonderful job in the industry, you know,
Okay.
because the industry demands the mechatronics engineers
Correct.
now.
So, if a student is coming into mechatronics, in terms of employment, what he should expect?
Okay.
And since you have been here for 25 years, 26 years, the department is there. Could you please throw some light on the placements that are happening in the mechatronics? So, yeah.
As I said, mostly all the students who have gone through the mechatronics, they have a very ample amount of opportunity in MNC, right?
Okay.
So the students who registered here in a placement cell, they will have a 100% chance.
100%?
Yes, 100% chance now to place themselves in company, right?
100%?
Yes, 100%.
Okay.
But I'm saying about the registered students,
Registered
right?
student, yes, of
Why I'm saying the registered students? Because those who have not registered, they have already made up their plan, you know.
Right.
They wanted to start their own venture.
Right.
Majority of the mechatronics students are from the industrial background, you know, like their fathers or maybe they have a good business from the industry.
Right.
And many of the students are planning their career in the abroad. So, you know, they go and join some university in USA, Canada, Australia, Germany.
Right. Most of the startups, they are coming from mechatronics students.
Yes.
So I remember one conversation with one of the mechatronics engineer. He said, factories create products, but we create factories.
Yes, exactly.
So it's like a paradigm shift for me. So obviously, if you see from the perspective of the future startups or the future technologies that are being generated, interdisciplinary is the mantra. I think it is already there in the mechatronics,
Yes,
as you
it is
say.
already there.
So, do you have any incubation center or a proper training center for them
Yes.
to innovate their ideas, creating the prototypes, and then demonstrate it to the venture capitalist, something like that? Is that kind of system available here?
Yeah. So in our university, there is a incubation center.
Okay.
So it's a government approved, right? Obviously, and many of our students, right? They have already registered their products, their firm into the incubation center as a startup.
Right.
They develop the products. They got the grant from the government, and using this grant, they have already started their own venture. I may give you some examples. Okay, one of our students, he has already started with the partnership of the other students.
Okay.
He already started to manufacture 3D printers in the
Okay.
Rajkot.
Really?
Yes, and they have come up with the new idea, and they, now they are working. They're well set now.
Okay.
Just I'm talking about 3 years back talk.
Right.
Similarly, we have many examples where the students will come up with the new ideas. Now coming to the facility, so startup will provide the all facilities which is required in for starting, like grant and many other small machineries
in order to create the first prototype.
Yes, for the first prototypes. But along with that, in our department, we have a very big workshop.
Right.
We have excellence centers.
Right.
So students will learn the many things here.
Right.
And excellence center is the only place where you can learn many hands-on experience.
Okay.
You have a much rich hands-on experience.
Right.
With the help of that experience, you can work on your product,
Right.
apply in the startup, and build a business.
Right.
So it's not only we create the factories, we create the business.
Excellent. So maybe they have to have the business knowledge as well.
Yes.
Because unless you make a profit out of it, you will not be able to create a big startup.
Yes.
That's great. Apart from the academic discussion, sir, when I just visited your center and all that, I can see here some machinery as well. It's like a childlike enthusiasm for me to understand what is all about. Okay.
Yes.
So I just want you to explain me the kind of the infrastructure you have, because it seems like very high tech and might be doing great things here. So I would like to understand.
Yes.
Okay. Shall we just see this one?
Yeah, sure.
Yeah.
So, as I said that in mechatronics, particularly the students who are interested in developing their career in robotics and automation,
right,
they normally take the admission, right?
Right. Yes.
So we have in department 2 excellence centers, which is exactly related or maybe directly related to the mechatronics.
Okay.
The first center of excellence what we have, that is automation technology. It's a technology which will automate the machines.
Okay.
Right? And when you want the automation in the machines, you need the applications of the various sensors and actuators.
Correct.
With the help of the electronics, we apply the sensors, actuators into the system.
Okay.
So that, and the control system. So with that help of these 3 basic items, we can do the automation.
So the sensors will take the data from the environment and they combine, integrate them, and then they take decisions and then they act.
Yes.
Okay.
But in order to understand the complete package, we have to see the step by step what are the things.
Right.
And for that, this automation technology is built.
Okay. So this machine is all about demonstrating that?
Yeah, it is just a demonstration of our mechatronics system itself.
Excellent, sir. Yeah.
Where the students, whenever some new comer is there, we normally explain them that this is how the mechatronics look like.
Okay.
Right? Actually, it is, as you already said, it is sponsored by the Boss Rexroth and the government.
Right.
So these equipments are from the Boss Rexroth. It represents the pure application of the mechatronics.
Okay.
What it does, this machines is actually assembling the 2 components.
Okay.
Right? One is a metallic part, other is a non-metallic part.
Okay.
And based on the proper orientation, it will assemble it, and that assembled part is going to be placed on the rack.
Okay.
This is what it does automatically.
Okay.
So actually what is doing
so
here,
it is a typical, in factories, typically this happens.
yeah, this is one of the typical example.
Exactly, yes.
This is one
the
of
most micro level work that is being done in the...
It's a programmable. Basically, this is a portable and programmable.
Excellent.
Maybe you can do the other task as well.
Okay, great.
So there is a application of PLCs. the machine have a 3 stations. This entire machine have a 3 station.
Right.
On the each station, certain kind of task is completed.
Okay.
So for example, here it will check the orientations, sensors are there. These are the sensors.
Okay.
So sensors will identify the metal part, non-metal part, orientation is okay. Once it is okay, the control system will send that part into the next station. So this is happening through the conveyors again. So it's a
conveyor belt,
fabrication
yeah.
line, you know, it is like a fabrication line.
In the factory, this application,
Yeah.
yes.
And on the second station, they will identify again the orientation and again they will put this part into the proper orientation, assemble them and send it to the other station.
Right.
Once they come into the entry point of the other station, the robot mechanism is provided.
So the positional, assembling will be done here.
Yes, on the second station.
Okay.
So assembling means it is a properly arrangement of the components.
The positional arrangement, yeah.
And once it is done, it will send to the third station where this robot will take that. It's a manipulator.
It's a robotic hand, sir?
Yeah, it's a robotic manipulator. It's a robotic system.
Okay, great.
It works on the pneumatic. Everything is working on the pneumatic, you know. So this is pneumatic system.
Excellent.
Sensor is there, so it's a sensor system.
Can we say like it's a miniature of a factory?
Yes,
something like that?
Yes. Itself, it's a miniature, and if I connect this system via port to the laptop, and if I control this thing, then it would be a cyber physical system.
Wow.
This is a cyber physical system.
Wow.
But I normally call it as a mechatronic system. But if you connect them, if you can reprogram it, it becomes a cyber, because it is connected through the internet and that way. So it's a closed loop control system basically.
Okay, yeah.
You know, this is not an open system.
Right.
You give some data, right? And based on the data, it will function. That algorithm will function.
Everything autonomous.
Yes, autonomous.
So the moment the first ignition, whatever the thing that we have to do, after that, it will automatically be done by itself.
Till it will put that system onto the rack.
The total workflow
is automatically done.
Absolutely great, sir.
So this is also a robotic application. As I said, it's one of the application.
I'm feeling like jealous of the students here because to imagine this kind of things available at the graduation level.
Yes.
I think the kind of fee structure you have is absolutely great. I think the Ganpat Garu, who are the founder of the university, he has very altruistic intentions for this, and he made all this available. I just want to quote it because I'm feeling it, just for 1.5 lakhs per annum.
Yes.
It's especially for at least the Telugu parents who are coming here.
Yeah.
I can see that, and the scholarship is applied for them.
Yes.
It's absolutely amazing.
So how that PLC is programmable?
Right.
So there we have a separate unit. So students are able to do the ladder diagram on the computer, transfer to the PLC, and that PLC will be operated based on the algorithm provided over here.
Wow.
So students will learn the hands-on training. You know, they have a hands-on learning and the skill improvement.
Sir, I'm just because I'm not technical that savvy.
Sure.
The algorithm, when you say algorithm, it is not a software algorithm, I feel like. It's a mechatronics workflow algorithm probably, right?
Algorithm means what? Okay, what you wanted to achieve.
A sequence of steps.
Sequence of instruction that you feeding into the control unit, or you feeding into the PLC, or you feeding into the any control device, or maybe in microcontroller or anything.
Okay.
There, based on your instruction, it will function.
Okay. The workflow has to be first sequentially you have to write it down, and then probably some or other way, as you just said, in the computer you have to
you have to put the ladder diagram.
Right.
Say for example, A task you wanted to do first, B task you wanted to do first, C task. So A, B, C, that will feed in terms of the instruction, and that will be executed.
Excellent, sir. Any other thing that we can see?
We can go there.
Right.
Actually, this is the first part of that automation technology.
Right.
Second part is on this side, other side of this lab.
Right.
So this is the other part.
Oh wow!
So this is the second part of the automation lab, where it's you can see there are different stations over here.
Right.
This is a training kit actually.
Okay.
And this training kit comprises of two parts. First part is the hydraulic system. Second part is the pneumatic system.
Okay.
On hydraulic system, as its name implies, it is on the oil.
Right.
So oil is used in order to function certain actuators.
Right.
And to actuate these actuators, we have to provide some circuitry body.
Right.
And these circuitry bodies are nothing but it is a combination of the different control valves.
Okay.
So based on the application of the industry, we teach the students how this circuit logically connected with each other.
Okay.
And based on the logic, we identify the components and we put the like hydraulic cylinder, single acting or double acting cylinders.
Right.
We combine them with this different control valves through these hose pipes, and the pressure is actuated those actuators.
Great.
So this is how the hydraulic system works, you know.
Great.
So it's just a one maybe to and fro motion of the cylinder, but for industry it's a very huge thing, you know.
Absolutely. Most of the manufacturing units they have big hydraulic systems inside it.
Yes, without hydraulic system you cannot generate that much amount of the force.
Yes, that's huge.
And same way, second part we have a pneumatic system where it operates through the air pressure.
Sir, just 1 minute, sir. I don't understand what is a pneumatic system. I understand hydraulic system.
Pneumatic system, it works on the air. It functions by the air.
Okay. Got
You
it.
know,
Instead of the oil, you use air here.
yes.
Okay.
In place of oil, we use air over here with the lower pressure. Normally 6 to 10 bar is the pressure of the air. There it is very high.
Okay.
Because there we have to generate too much force.
Right.
Here, the pneumatic air is going into the FRL unit and subsequently based on the logic, through the control valves, it operates the system.
Excellent.
As we have seen in the mechatronics kit.
Right.
You know that robotic arm, when it is picking and putting, for that the pneumatic cylinders are used. Such
So
a cylinders
the motion is actually generated through the pneumatic system.
Yes, that is through the air.
Excellent.
So robot is operated through the air.
Sir, actually every part of manufacturing is covered here. It seems like that for me.
Yes. Everything is covered.
And that's how that guy told, your factories create products, but we create factories.
Yes. And we also create business.
Right.
So it's not only about the pneumatics and hydraulics. We operate the system through the, various relays,
Okay.
It's an electro-pneumatic system, or there it is called the electro-hydraulic system.
Okay.
So through the computer, we can make a circuit.
Okay.
And the circuit, according to the circuit, the control valves will be actuated through these relays,
Okay.
So those valves are operated through the electrical signals. So, again, we have to connect them according to our logic.
Okay.
And circuit we have to make according to our logic. But, we do the research as you are speaking.
Yeah.
Okay, suppose something we have to debug or something we have to test new thing, then we can debug on this computer. We can send it to the real system. So it's a purely application of the computer, electrical, and the mechanical.
Yes.
So it's a combination of them.
Great, sir. Great.
Many of our students, they have participated in various national level, even international level, and they won the prizes. It's not like that. Many of our students won the RoboFest competition in Gujarat.
Okay.
They won, like on the robotic, there is a self-balancing robot, they won 5 lakhs rupees.
Okay.
Library assisted robot, they won 10 lakh rupees. So there are many students from our department who regularly, even I'll tell you, it's a right day for this interview because today is the, I think, Tuesday, right? So Tuesday, the people from like 6 students from Mechatronics department, along with the 1 faculty member, they are going to China for underwater competition.
China?
Yes.
From this department?
Yes. If you wish some references and material, I will send you.
No, that is fine, sir. But just to the kind of exposure here, I think it's incredible. As part of the graduation studies, they are going to China.
And they are in the...
It's a manufacturing gained.
Yes.
And there you are getting exposure to the underwater robots, sir?
Yes, underwater robot competition is there. It is going to be held in China.
You guys have created something?
Yes, we have created underwater robot. It is functioning well. We have our sports facility, swimming pool. We have tested there and we are sending them.
Outstanding work. I don't know any words for it actually. But yeah, I think you have...
Yes,
there is some other
we have a other excellence center.
Right.
Please come. वहाँ से किसी को लेना है? वहाँ से मैं बोल देता हूँ.
No problem. We'll go like this. No problem. Yeah.
So they are going depart today.
Oh,
for China.
But really,
Dr. V.D. Patel and 5 students from Mechatronics, 6 one is from IT.
Okay.
6 people are going.
Okay. Fine. Right.
We call it as a National Additive Manufacturing Center, West Zone.
Okay.
The government has given this facility.
Government?
Means the government is given the grant.
So why it is very important for the national causes, or what it is? Why it is so important for government to sponsor it? Yeah,
because government is looking for a university where students will have a exposure of multidisciplinary domains.
Okay.
So if the government found that the Gujarat and particularly Ganpat University has got the opportunity. They have a very good landscape in the academia. Then probably this is the best. And we have many other facilities. So of course the students not only learn the one field knowledge, they will have exposure of many multidisciplinary knowledge, and they can expose that. So I think
multidisciplinary engineering is very important for government.
Obviously, for government as well as for the industry as well as for the institution.
Excellent, sir.
To grow any to grow, I mean to say, for any students growing, the multidisciplinary application is very important.
Yeah.
Right. Now, let me come to the point. This National Additive Center, what we call the additive manufacturing, this is also called as a 3D printers, you know.
Oh, yeah, yeah.
You might have heard the word 3D printers.
Yes.
When you go to nearby places or industry, the people say that this product is manufactured through the 3D printers.
No, even we keep hearing in the internet, there are 3D printers who building the homes as well.
Yes. So actually, there are huge applications of the 3D printers.
Okay.
So excellence centers right now we have, we have got a very good 3D printers, you know.
Okay.
So this is one of the 3D printers.
This is 3D printer, sir?
Yeah, this is a big 3D printers. And you can, I just tell you, this much size of the part you can prepare.
So this is...
Why this is important? Because it's a very complicated geometry, you know.
Sir, recently what happened?
Yeah.
There is one startup in Hyderabad. They have printed the combustion engine for rocket.
Yes.
With 3D printing only.
Yes.
Because what they are saying is, if you weld the materials, there is a thin line separating it.
Yeah. So it's not a perfect manufacturing.
Exactly.
So additive technology is there. Why we call the additive manufacturing? Because we add the material layer by layer.
Right.
To form a shape.
Right.
So here, the 3D printers, what it does, it will layer by layer deposit the material, and these way the 3D is printed.
Okay.
The 3D component is printed.
Okay.
Now there are different materials you may use. Here we have a status machine. So probably the materials from the status is been given. So those materials are used. But if you say in general, the 3D printers can be used. They can use the different materials from plastic, metal, even the metal printers we are going to procure.
Right.
So of course the application of the 3D printers is only for the kind of job. You see that this is the Devi Murti created through this 3D printers, you know.
Right.
So material.
So, intricate details are being given.
Yes.
Smallest of the smallest is.
The CAD part is prepared. The CAD part is going to the slicer and the data is sent to the machine, and then it will be manufactured. So this is one of the application. I mean to say, when you talk about the mechanical, when you talk about the mechatronics, this plays a dominant role.
Sir, can we just understand what it is, what it does, and how the...
Yeah. As I said, it is 3D printers. So
the material is fed through.
Yeah.
From
So I'll come to this point. See, the material used, it's the ASB, ABS, and the ASA.
Okay.
So it's a thermoplastic materials.
Okay.
As I have shown to you.
Okay, got it.
Right. So these are the potential customers. So it is application is not limited.
So it's more of polymers only.
Yes, polymers. These machine use the polymers, but there are 3D printers available which can use metals.
Okay.
It may be aluminum alloy, it can be a steel, it could be any material, like metal can be used. Yes.
Okay. That printers are here?
That we are planning to procure in the next month.
Okay, great. So metals also we can...
Yes, metal.
But how the metal is fed? Because it is too...
So heat generation, we have to produce that much amount of it. We have to take that metal to the
very high tech.
Yes, very high temperature based on the material type.
Okay, great. So these are all the small scale of...
It's a small scale machine. So for smaller project, we can use...
As you have shown that...
Yeah. Even I will show you this MediJet.
Okay.
This MediJet application, if you see, it is used also for the medical purpose.
Medical purpose.
So you might have seen that implants are used, you know.
Right.
So the implants
dental
are
implants.
yes, metal. This metal implants, even the
correct.
The dentist implants, what you say,
right?
They use 3D. They are the 3D printers.
They are perfect actually, because that size is actually you cannot you have to create a mold for it, and then you have to get it, and then you have to create the
And I'll add to this point. It's not only the internship provided to the mechanical and mechatronics students, those who are residing outside, but also students of biomedical, students from biotechnology, they can also collaborate with the mechanical department and they can generate a research work, you know.
Absolutely great. Absolutely
So
great.
this is how we call the interdisciplinary branch. In mechatronics, right now we don't have a digital twin, but we are planning to introduce a new subject that is a digital twin, you know.
What is that?
It's a technology where suppose a machine is working, right? Some machine is performing some job, or it is under the working real condition, real environment. And the data from that machine is collected on the computer, and there we have a digital twin of that original machine.
Yeah, I got it. Yes.
Yeah.
Okay.
So
it's a kind of a simulation of the actual machine on the control panel.
Yeah, but that control, now this is not only single way.
Okay.
It is not only SCADA, you know.
Okay.
So there, suppose something is happened there, we can control from that simulation model to the original one, real one.
So the two-way.
Yes, it's a two-way communication. That is why it is a digital twin. The name stands for the digital.
Great. It's all said and done, sir. The last question I am getting, and probably some of the students also have there in mind. Do the student has to be extraordinarily intelligent to get into mechatronics?
No, that's not required at all.
Right.
Because he is going to be engineer only.
Right.
The common sense always plays very important role.
No, this is a myth or a perception that people have it. Yeah.
No. For them, they should have just a willpower to learn something new. If you are ready to learn the new things every semester, every year, or maybe subsequent after the 4 year, then he can be a good mechatronics engineer.
Thank you, sir. Thank you very much for joining us.
Thank you so much.